Okay, let's give you guys some more practice. So find the limit of this as x tends to infinity. So press pause and have a go. Okay, so to do this, let's just say the limit here is y. Let's just say the whole limit here is y. Now natural log both sides. So when you natural log this will come down. That will then give you this. You've got your natural log here, and then whatever here, and then you've got whatever here. So now now this. So now you've got one block multiplying another block. This block gets multiplied to the top. So visualize it like this. And then let's check. As x tends to infinity, this thing here will head. Well, as x tends to infinity, you've got one bubble plus one. As x tends to infinity, this bubble here is going to be massive. This one's going to be irrelevant. So as x tends to infinity, even though you've got one thing plus another thing, this thing here is going to be useless. It's going to be irrelevant. So as x tends to infinity, this thing here really boils down to x squared. And then as x tends to infinity, down here you've got one thing plus the number 2. As x tends to infinity, this 2 is going to be irrelevant. So this whole thing here is just going to, well, you can just consider it as x. So here you've got x squared, and then down here you've got over x. So you can consider this as what, divide top and bottom by x. That will then give you this. As x tends to infinity, this whole thing here is heading towards infinity. So as x tends to infinity, this whole thing here will head towards infinity. Now, if you look at the natural log, if you look at the natural log graph, it will look something like this. As x tends to infinity, you are heading towards infinity. So this thing here is heading towards, this whole thing here is heading towards infinity. And then down here, as x tends to infinity, this thing is also heading towards infinity. So here you've got infinity over infinity, so you can apply L'Hopital's rule. But by the way, before you do that, you should use your gut instinct. When you get to this stage here, you should be able to use your gut instinct. Here you've got natural log of something that's heading towards infinity. So if you look at this graph here, you've got the natural log of something that's heading towards infinity. But then if you look at this, y equals x here will climb a lot faster than the natural log of x. So this thing here is going to head towards infinity a lot faster than this. Well, hang on. If you get to this stage here, look at this. If you get to this stage here, your natural log of x looks something like this. Your square root is also climbing. Square root climbs a lot faster. Well, it climbs faster than the natural log of x. But then if you look at y equals x, it climbs a lot faster than the natural log of x. So when you look at this, this is heading towards infinity. But the thing is, this thing here is heading towards infinity a lot faster than this thing here. So you eventually you're going to get something very, very you're going to get something that's very big divided by something that's very, 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 very big. So of course the whole thing is going to head towards 0. So when you get to this stage here, have a bit of develop a bit of your gut instinct, and you should be able to recognize that this is heading towards 0. But let's just get back to where we were. We were at a stage where it's infinity over infinity. Because it's infinity over infinity, we're going to apply L'Hopital's rule. So differentiate this and then differentiate this. So hang on. So because this thing here, we've got infinity over, and then this thing here, infinity over infinity, we can apply L'Hopital's rule. So differentiate this, that will then give you this whole thing here. Differentiate this, that will then give you this one here. So when you come to differentiate this, imagine it as natural log of the bubble here. So when you differentiate it, it would be 1 over the bubble, which is really the reciprocal of this. That's why you've got this thing on the top, and then this thing here at the bottom. So that's this bit here, and then you've got to times the derivative of the bubble itself. So the derivative of the bubble itself is this bit here. So you've got to use the the quotient rule here. Okay, so well, think about it. If you differentiate this, it will then give you this. So now it's just a matter of tidying up. So here, this is exactly the same as this. So this will cancel out, and this will cancel out with this thing here, and then that will then give you this. That will then give you this, and then blah blah blah, tidy up, and then that will then give you this. So now now when you get to this stage here, tidy up again. So so that will then give you, well, it will then take you to this stage here, and then when you get to this stage here, yes, you could divide everything by x squared divided by x squared divided by x squared divided by x squared, and so on. You could do that, but if you look at this here, as x tends to infinity, you've got one thing divided by another thing. As x tends to infinity, if you look at the numerator only, if you look at the numerator only, you've got this thing plus this thing, take away this thing. As x tends to infinity, this is going to be irrelevant, this is going to be irrelevant. So just think of the numerator as x squared, because as x tends to infinity, this thing is going to be irrelevant. So let's just consider it as x squared. Now let's look at the denominator. As x tends to infinity, this thing is going to be irrelevant. So let's just consider it as x to the power 3. So now divide top and bottom by x squared. That will then give you this. Well, as x tends to infinity, this thing here is going to head towards 0. So this whole thing here is actually heading towards 0 here. So now e from here, e equally to both sides. That will then give you this, and then in a way these two cancel out, giving you y here. So the limit is actually heading towards 1. So if you get a graph plotter, plot it. If you get a graph plotter and plot it, as x tends to infinity, it is heading towards that blue line, which is y equals 1 here. It is heading towards 1. Okay.